Hello. In this video, I'm going to explain how you can use Opamp for implementing Schmitt Trigger using Opamp using Multisim tool. So the first is actually the Schmitt Trigger, which is basically is a comparator which compares negative terminal voltage with plus terminal voltage. So input voltage is actually 5 volts peak to peak. So you should know the formula to find what is UTP and LTP for this. Okay, because when the input voltage is greater than UTP, okay, always output will changes from minus V naught to plus V naught side. So in the zero crossing detector and with reference voltage, we actually tested op-amp comparator and the output changes. Instead of one fixed voltage, we can also compare op-amp voltage with op-amp input with this op-amp comparator. Instead of comparing with one voltage, we can compare with the two voltage values. Okay. First voltage, that is LTP, another voltage is UTP, okay, lower threshold voltage point or upper threshold point. So when input crosses these two levels, okay, any of these two levels, when the input crosses that level, output changes from one to another one. Okay, so now this is the op-amp. You can choose any one. Okay, either you can choose a UA means MUA 741 CD. You can select a place component. I'll show you one at least. Okay, place component. You have to stop running place component. In the component, go to Opamp, analog 741. You can select this also, UA741, or you can type here UA741 CD. You'll get anything, anyone. You can use CP also, you can use MJ also, anything you can use. So any 741 series you can connect here. It has two inputs, minus plus. 7 is it uses dual power supply. 7 is positive. See the pin nearer to this plus, it is positive, and minus negative voltage. So V and VCC. So how to place V and VCC? Place component, go to power supply, so group sources. There you can get VCC and VE. By default, it will have 5 volts. Double click and change that value to minus 12 volts and plus 12 volts and minus 12. So you have to place VE and VCC from sources, power sources. There you have to select. And this is a AC voltage source. How to place this one is place component, go to sources. There single voltage source is there. Single voltage source. After clicking this, you have to select AC voltage. This, if you click OK, it will come and change the value. Double click and change the value to 5 volts, frequency to 50 hertz. And next to resistor, go to right click, place component, go to basics. In that basic resistor, you select, or you can directly click here and place and double click and change the value to 3.9K and 1K. And this design is for some UTP and LTP at values. Check if it is there, I will show. Otherwise, you have to refer some formulas. I'll check here whether it is there or not. No, let me see. Yeah, for UTP plus 2 and minus 2 volts. Okay. UTP formula you can see here. LTP is R2 divided by R1 plus R2 into minus V naught SAT. UTP is R2 divided by R1 plus R2 into plus V naught SAT. So it is a voltage divider. R2 divided by this UTP is R2 divided by R1 plus R2 into V naught SAT. Okay. So that is nothing but voltage drop across R2. So here, whenever the voltage is output is always output of comparator is plus V naught SAT or minus V naught. Whenever it is plus V naught SAT, current in this path is uh, voltage divided by resistance. Okay, V naught SAT divided by R1 plus R2, and drop across R2 is your reference voltage. So whenever this is positive, plus V naught sat divided by R1 plus R2 into R2 is the UTP value, and LTP is, and the output is minus V naught sat divided by R1 plus R2 into R2, and we know that current entered into the terminals are 0. Here 0 current is going to flow. So we have to assume that almost all the current will flow go ground only. So that's why potential difference is V naught divided by 0 divided by R1 plus R2 is the current. That current multiplied by, and two possibilities of output are plus V naught sat and minus V naught sat, and the output is plus V naught sat. We call the reference voltage across R2 as UTP, upper threshold. When the output is minus V naught sat, same drop across R2, now we call it as LTP, lower threshold output. Input is compared with UTP and LTP. According to that, output will change. Okay, so the design for UTP and LTP, I think we are having R1 and R2 as 3.9 and 3.9 and 1K. So I think 3.9 and 1K is used, 3.9 and 1K is used to have hysteresis curve at output changes to minus 2 and plus 2 volts. So now we'll run this, double click on this, you can check LTP, this side is plus 2 volts, and UTP is plus 2, LTP is minus 2. And if this is AB means hysteresis curve. If you give y slash t, you can see input is sinusoidal waveform. Whenever input crosses 2 volts plus 2 and minus 2, I'll click single. Okay. Whenever input crosses plus 2, output changes from plus V naught to minus V naught side. And the input crosses minus 2, again output changes from minus V naught to plus side. Output of comparator is always square wave. This is square wave is the output. I will ground another one. This is always output of comparator is plus or minus V naught sat. Okay. Now if you have input, we already seen zero crossing detector. Whenever input crosses 0, output changes. Now instead of that, we are having two reference voltages, UTP and LTP. Output is actually changing whenever input wave crosses plus 2 volts. Whenever input crosses minus 2 volts, output changes from one state to another state. And hysteresis curve is obtained by input versus output. And this is if you are obtaining for 50 hertz. If you give 1 kilohertz and all, you will get many harmonics. Some 4-5 lines will be visible. That's why you give less frequency, 50 hertz. Okay, this is same UTP and LTP, only sign is changes. Similarly, we can also design one more design, UTP 3 volts, LTP minus 2 volts. Okay, UTP 3, LTP minus 2 volts. For this design, if you calculate R1 and R2 using that formula, you are going to get 3.9, and R2 is equal to 1 kilo ohm, and reference voltage is also you have to place, that is 0.63. Okay, so that is actually 0.60 there. I think this is for different design. Okay, let us see this for this UTP and LTP. You have to use this one. I think here reference voltage is different. Okay, in the circuit diagram, reference voltage is 2.6, and R3 is 22K, R4 is 1.2K. So for this, let us see what is the output. It is already running. So if I double click this, okay, we are getting the output. Getting both positive only. Okay, if you want have different, okay, this is I think plus 2 and plus 4, I think. Okay, plus 2 plus 4, UTP 4, LTP 2. So for this also I will change this one to, instead of 500 hertz, I will change it to 50 hertz. Now run this. Click A slash B. These 4-5 lines are coming visible. That's why always you should try to give less frequency so that this run properly. I'll still reduce frequency values to just to 10 hertz. I'm once again running. You're getting, yeah, this is one division is equal to how much? 5. Okay, x is 5. So this is 0.6 and 0.8. 6 into 5 is 3 and 6 into 6. So 6 into 8. You're going to get here LTP, this is UTP. Okay. And let us check this one more design they have. 3.91K. That is for another design. Plus 3 and minus 2. Plus 3 and minus 2 with reference voltage. I am changing this value to reference voltage. How much we got? 0.63. This is 3.9 only. Let's change the value to any other value. Point 9K. This is 1. This is 0.63. And this is 1 kilo ohm. Okay, now let us verify whether the design is correct or not. Minus 2 and plus 3 na. Let us check. Yeah, minus 2 LTP minus 2 UTP is 3. The formula for different with reference voltage it is R1 V reference divided by R1 plus R2 into R1 plus V naught divided by R1 plus R2 into R2. So you can refer any textbook with reference what is the formulas. So by putting UTP3 and LTP minus 2, you have to simplify the equation, and finally you should you will get what is the ratio of R1 and R2. After that, assuming R1, R2 value, you can find out R1 value, and you can also find out reference voltage value. For this reference voltage is coming 0.63, and if you substitute that, you're getting LTP as minus 2 here, and UTP is plus 3 volts. Okay, if you give more frequency, 1 kilohertz per kilowatts, you will get many lines here. Okay, so try to give less frequency. Here I given only 10 hertz. So this is Schmitt trigger, which compares input voltage with two reference voltages, and here we are using one more reference here, but this one is Schmitt trigger without any reference voltage. Okay, both in LTP and UTP are same value, plus or minus 2 volts, plus or minus 3 volts, plus same UTP and LTP same, only sign will changes. But here you can also change different UTP LTP. Okay, for this we need reference voltage also. Okay, thank you.